According to the National Electrical Code (NEC), dedicated neutrals are still required for lighting circuits feeding fluorescent lighting, regardless of the type of ballast used. Harmonics are distortions in the sine wave of the alternating current (AC) supply. Fluorescent lighting fixtures with magnetic ballasts generate significant harmonics, which can cause interference and overheating in other electrical devices. Electronic ballasts reduce harmonics compared to magnetic ballasts, but they do not eliminate them entirely. Sharing neutrals in lighting circuits with fluorescent lighting can lead to, firstly, voltage imbalances, secondly, overheating of neutral conductors, thirdly, false tripping of circuit breakers, and fourthly, reduced efficiency of lighting fixtures. Section 220.61. C of the NEC requires that each lighting circuit that supplies fluorescent lighting fixtures with magnetic or electronic ballasts must have a dedicated neutral conductor. Although electronic ballasts generate fewer harmonics than magnetic ballasts, dedicated neutrals are still required for lighting circuits feeding fluorescent lighting to comply with the NEC and ensure safe and efficient electrical operation. The necessity for dedicated neutrals in fluorescent lighting circuits stems from the nature of harmonic currents and their impact on the electrical system. Understanding harmonics and their effects is crucial for ensuring a safe and efficient electrical installation. Let's delve into the details of harmonic currents. Harmonic currents are currents with frequencies that are integer multiples of the fundamental frequency, which is typically 60 Hz in the United States. These harmonic currents are generated by nonlinear loads, which are devices that draw current in a non-sinusoidal manner. Fluorescent lighting, especially when using older magnetic ballasts, is a significant source of harmonic currents. While electronic ballasts reduce the generation of these harmonics, they do not eliminate them entirely. The primary concern with harmonic currents is that they can overload the neutral conductor in a multi-wire branch circuit if the neutral is shared among multiple lighting circuits. In a balanced three-phase system, the neutral conductor theoretically carries very little current because the currents from the three phases cancel each other out. However, harmonic currents, particularly the third harmonic and its multiples, are additive in the neutral conductor. This means that instead of cancelling out, the third harmonic currents from each phase add together in the neutral. This can result in a neutral current that is significantly higher than the current in any of the phase conductors. Overloading the neutral conductor can lead to several problems. Firstly, it can cause the conductor to overheat, which can damage the insulation and potentially lead to a fire. Secondly, the increased current can cause voltage drops along the neutral conductor, which can affect the performance of other equipment connected to the same circuit. Thirdly, the harmonic currents can interfere with the operation of sensitive electronic equipment. NEC Section 220.61. C addresses this issue by requiring that each lighting circuit that supplies fluorescent lighting fixtures with magnetic or electronic ballasts must have a dedicated neutral conductor. This means that each lighting circuit must have its own neutral conductor that is not shared with any other circuits. This helps to prevent the overloading of the neutral conductor and ensures that the electrical system operates safely and efficiently. The specific requirements outlined in NEC Section 220.61 C are designed to mitigate the risks associated with harmonic currents in fluorescent lighting circuits. Compliance with this section is not just a matter of following the code, it's a critical step in ensuring the safety and reliability of the electrical system. Firstly, the code mandates a dedicated neutral conductor for each fluorescent lighting circuit, whether it uses magnetic or electronic ballasts. This is to prevent the accumulation of harmonic currents in a shared neutral, which, as mentioned, can lead to overheating and other issues. Secondly, the size of the neutral conductor must be adequate to carry the anticipated load, including the harmonic currents. The NEC provides guidelines for calculating the neutral load, taking into account the type of lighting and the expected harmonic content. Thirdly, the code also addresses the issue of voltage drop. Excessive voltage drop can negatively impact the performance of lighting fixtures and other electrical equipment. Therefore, the NEC specifies the maximum allowable voltage drop for lighting circuits. Understanding these requirements and how they apply to fluorescent lighting circuits is essential for electrical contractors, engineers, and inspectors. It ensures that lighting systems are installed and maintained in a manner that meets safety standards and promotes energy efficiency. Furthermore, it's important to note that while electronic ballasts reduce harmonic currents compared to magnetic ballasts, they do not eliminate them entirely. Therefore, the requirement for dedicated neutrals remains in place, even when using electronic ballasts. This is because even the reduced harmonic currents from electronic ballasts can still accumulate in a shared neutral and cause problems. In addition to dedicated neutrals, other measures can be taken to mitigate the effects of harmonic currents in electrical systems. These include using harmonic filters, which are devices that block or reduce the flow of harmonic currents, and using transformers that are designed to handle harmonic currents. Harmonic filters are typically installed at the point where the harmonic currents are generated, such as at the lighting panel. They work by creating a low impedance path for the harmonic currents, which diverts them away from the rest of the electrical system. Transformers that are designed to handle harmonic currents typically have a larger K-factor rating. The K-factor is a measure of a transformer's ability to withstand the heating effects of harmonic currents. A higher K-factor rating indicates that the transformer can handle high levels of harmonic currents without overheating. In conclusion, dedicated neutrals are still required for lighting circuits feeding fluorescent lighting, regardless of the type of ballast used. This is because harmonic currents, even at reduced levels, can still accumulate in a shared neutral and cause problems. Compliance with NEC Section 220.61 C is essential for ensuring the safety and efficiency of electrical systems that supply fluorescent lighting. By understanding the nature of harmonic currents and the requirements of the NEC, electrical professionals can ensure that lighting systems are installed and maintained in a manner that meets safety standards and promotes energy efficiency. The information emphasizes the continued need for dedicated neutrals in fluorescent lighting circuits due to harmonic currents, even with the use of electronic ballasts. This is a critical aspect of electrical safety and code compliance that professionals in the field must be aware of. To further illustrate the importance of this requirement, consider a scenario where multiple fluorescent lighting circuits share a common neutral conductor. If these circuits are heavily loaded and generate significant harmonic currents, the neutral conductor can become overloaded. This overloading can lead to a variety of problems, including firstly, overheating of the neutral conductor, which can damage the insulation and create a fire hazard. Secondly, voltage drops along the neutral conductor, which can affect the performance of the lighting fixtures and other electrical equipment connected to the same circuit. Thirdly, interference with sensitive electronic equipment due to the presence of harmonic currents. In contrast, when each lighting circuit has its own dedicated neutral conductor, the harmonic currents are confined to that circuit and do not accumulate in a shared neutral. This reduces the risk of overloading the neutral conductor and helps to ensure that the electrical system operates safely and efficiently. The NEC Section 220.61 C is very specific in its requirement for dedicated neutrals in fluorescent lighting circuits. The language is unambiguous, leaving no room for interpretation. This underscores the importance of this requirement and the need for strict compliance. Moreover, it's essential to recognize that the NEC is a minimum standard. In some cases, it may be necessary to go above and beyond the NEC requirements to ensure the safety and reliability of the electrical system. For example, in situations where there are particularly high levels of harmonic currents, it may be necessary to use harmonic filters or other mitigation measures in addition to dedicated neutrals. Furthermore, it is important to consider the long-term implications of using shared neutrals in fluorescent lighting circuits. While it may seem like a cost-saving measure in the short term, the potential for problems down the road can outweigh any initial savings. Over time, the overloading of the neutral conductor can lead to premature failure of the electrical system, resulting in costly repairs and downtime. Additionally, the presence of harmonic currents can shorten the lifespan of lighting fixtures and other electrical equipment. Therefore, it is generally more cost-effective to install dedicated neutrals from the outset rather than trying to correct problems later on. It's also crucial for electrical professionals to stay up to date on the latest developments in lighting technology and electrical codes. As new technologies emerge and codes are revised, it's important to understand how these changes affect the design, installation, and maintenance of electrical systems. For example, newer types of electronic ballast may generate even lower levels of harmonic currents than older models. However, even with these advancements, the requirement for dedicated neutrals may still be necessary to ensure the safety and reliability of the electrical system. In summary, the requirement for dedicated neutrals in fluorescent lighting circuits is a critical aspect of electrical safety and code compliance. By understanding the nature of harmonic currents and the requirements of the NEC, electrical professionals can ensure that lighting systems are installed and maintained in a manner that meets safety standards and promotes energy efficiency. This not only protects people and property from electrical hazards, but also helps to ensure the long-term reliability and performance of the electrical system. Additionally, consider the implications of non-compliance with NEC Section 220.61. Failure to install dedicated neutrals in fluorescent lighting circuits can result in a number of negative consequences, including firstly, code violations, which can lead to fines and other penalties. Secondly, increased risk of electrical fires and other hazards, which can endanger people and property. Thirdly, reduced performance and lifespan of lighting fixtures and other electrical equipment. Fourthly, increased energy consumption and higher utility bills. Fifthly, potential liability in the event of an electrical accident or fire. Given these potential consequences, it is clear that compliance with NEC Section 220.61 C is not just a matter of following the rules, it's a matter of protecting people and property from harm. Electrical professionals have a responsibility to ensure that all electrical installations are safe and code compliant, and this includes adhering to the requirement for dedicated neutrals in fluorescent lighting circuits. The topic of harmonics and dedicated neutrals is a complex one, and it is important for electrical professionals to have a thorough understanding of the underlying principles. This includes firstly, understanding the nature of harmonic currents and how they are generated. Secondly, understanding the effects of harmonic currents on electrical systems. Thirdly, understanding the requirements of the NEC with respect to harmonic currents and dedicated neutrals. Fourthly, understanding the various mitigation measures that can be used to reduce the effects of harmonic currents. With this knowledge, electrical professionals can design, install, and maintain electrical systems that are safe, efficient, and reliable. In addition to the technical aspects of harmonics and dedicated neutrals, it is also important to consider the human element. Electrical professionals have a responsibility to educate their clients about the importance of code compliance and the potential risks of non-compliance. This includes explaining the need for dedicated neutrals in fluorescent lighting circuits and the potential consequences of using shared neutrals. By communicating effectively with their clients, electrical professionals can help to ensure that electrical installations are safe and code compliant. The concept of total harmonic distortion, or THD, is also relevant in this discussion. THD is a measure of the amount of harmonic content in a waveform, expressed as a percentage of the fundamental frequency. A high THD indicates a significant amount of harmonic distortion, which can lead to the problems discussed earlier, such as overloading of the neutral conductor and interference with sensitive electronic equipment. Electronic ballasts typically have lower THD values than magnetic ballasts, but even with electronic ballasts, the THD can still be high enough to warrant the use of dedicated neutrals. The NEC does not specify a specific THD limit for fluorescent lighting circuits, but it does require that the electrical system be designed and installed in a manner that minimizes the effects of harmonic currents. This includes the use of dedicated neutrals, as well as other mitigation measures such as harmonic filters. To determine whether dedicated neutrals are required for a particular fluorescent lighting circuit, it is necessary to consider a number of factors, including firstly, the type of ballast used. Secondly, the number of lighting fixtures on the circuit. Thirdly, the length of the circuit. Fourthly, the load on the circuit. Fifthly, the THD of the current waveform. In some cases, it may be necessary to perform a harmonic analysis to accurately assess the amount of harmonic distortion present in the circuit. A harmonic analysis involves measuring the harmonic content of the current waveform and comparing it to the limits specified in the NEC and other applicable standards. The results of the harmonic analysis can then be used to determine whether dedicated neutrals are required and to select the appropriate mitigation measures. Electrical safety is paramount, and the NEC provides the guidelines to ensure that electrical installations are safe and reliable. Adhering to the code, including the requirement for dedicated neutrals in fluorescent lighting circuits, is essential for protecting people and property from electrical hazards.